what happens here for a real good introduction of what a piecewise function looks like is you're making 10 bucks an hour for so long, and then all of a sudden you're making $15 an hour. This graph, once it hits that 40-hour mark, is it going to increase more or is it going to decrease? Increase, because it's no longer going at $10 an hour, it switches to $15 an hour. That's what they call a piecewise function. It's two functions that are, or two equations that are built onto one graph, and they're dependent upon the domain. You guys remember what domain meant? The x values, yeah. The x values. You had domain and range. Domain were the x values, range was your y values. So these piecewise functions are what we call domain specific. They're dealt with the x values. The x values drive what happens. But what we need to do before we get into graphing and plotting and looking at this type of stuff is to understand what it means to read it and to understand the notations behind it. So what we do is we look at stuff like this. F of x. You've seen that, right?
Well, I thought it was 2x because the way your first parentheses looked like a curvature.
Come on, it's been like a week. Haven't you figured out my handwriting yet?
A little bit.
I know. My handwriting is not good. F of x. You guys have all seen that before, right?
Yeah.
That's kind of like the other idea as this. Kind of means the same thing for all intents and purposes. X is a function, or a function of x, y equals, all kind of works the same here. They're kind of interchangeable. The reason why I say that they're interchangeable is because on your calculators, there's a button. There's a button that says y equals. So what I want to do here today is kind of go over with you guys what it looks like to be function notation and how to use your calculator to create some tables and stuff like that. And then we're going to use the actual substitutions. So what I'm going to do here is kind of give up a real easy equation. F of x equals x plus 2. And what I want you to think of is that that kind of means the exact same thing as y equals x plus 2. So let's go to our calculators. I don't. There we go. Go to the y equals button, and let's just type in x plus 2. Make it really, really, really easy. Eventually.
It's right next to x plus 2.
X plus 2, which means we have to know how to type in x plus 2. On your calculator, everybody sees where the alpha, everybody got to the y equals, okay, right? All right. Now you see the button that says alpha. Go to the one to the right of it where it says x, t, theta, and n. That gives you your variable. All right. That gives you your variable. And then the tough part. I know. Go slower if you need. All right. So you're just typing x plus 2. Now hit the button that says graph. With any luck, it should look like that. A lot of times, it doesn't. Because your calculators need to be reset. Now, one thing to remind you guys of, is your axis off? It's all out of whack?
Yeah.
Okay. This is a great example of what to do when everything goes bad. Well, yeah, everything's weird right now. What happens is, if all else fails and everything looks kind of weird, graph's all messy, it's got squares in it. Might be operator error, I don't know. You're just kind of the same thing. There's a way to reset it. Yes, this will help with your reset as well. His is saying there's an invalid dim. Means the way that the window is set is all messed up. Now this happens all the time. As students get flustered because they don't know how to fix their calculator. How do you fix your calculator when you don't know what's going on? You press these sequence of buttons. Second plus 712. It clears the RAM. Second plus 722. And it resets everything to the default. Now, if your grid, Michael, your grid was all messed up, everything was shifted over, you always saw it was the first and fourth quadrant. Willis, you had squares.
Yep.
Not a blue one. Now if you go back to your y equals and retype that in, x plus 2, you should be all good now.
Oh, would you look at that?
It's crazy how that works, isn't it?
Yeah.
That happens. Did it work for yours too?
Yeah.
Yeah, and that happens all the time, is that if your calculator gets dropped, you lend it to a friend, they draw nasty pictures on there, they type wrong stuff on there, they mess with your windows. It happens all the time. Those of you guys that take physics, are you taking physics? You're going to be messing with your calculators all the time because you guys do a lot of programming in there. Your windows are going to go away, your axes are going to get turned on, turned off. Chemistry, they do that a lot too, where they mess around with the graphs on there, on the actual windows. You can create and shift that around. So like on yours, Michael, how it was just showing the first and fourth quadrant. If you wanted just to be a specific quadrant, you wanted to look at the graph just in a little area, there's a button here that says window. If you press that window, it gives you your range of your x values and the range of your y values. You can shift them anywhere you want.
Oh, yeah.
So you can be 0 through 10 just to give you the first and fourth quadrants if you wanted. You can be -10 to 0 for the second and third quadrants. You can move that around. Sometimes we like to make the graphs really, really, really big so we can see intercepts that are way up high. Just if we don't see things right away, we can mess with our windows. And it allows you to move and shift and see stuff that's occurring. It also helps a lot when we start talking about intersection points and where things are changing direction, things like that. We can zero in around certain specific points. It's really a nice tool to be able to use as long as you know how to press the right sequence of buttons. So if you change your windows, you mess around with any of it, and all else fails, you can always reset it by that second plus sign 722, and it'll go back to normal. Okay? Does that make sense?
Sure.
All right. Now, the other really, really cool thing about the calculator is if you press second graph, you're going to get to a table. And that gives you a table set of values. Basically, it tells you when x is 0, y is 2, when x is 1, y is 3, when x is 2, y is 4, and so on and so forth. What it's doing is substituting in the values for you. So if you're the type of person that makes mistakes when you have a lot of negative values and you're squaring them, -2 squared sometimes happens to be -4 in your mind, this will alleviate that from happening. On ACT tests, you see stuff with multiple, you see order of operation style problems with function notation. I'm going to show you guys how you can type that in your calculator and go to the table, and it gives you the answer real fast. Okay? So here's what I wanted to look at. We're looking at that function, that f of x is x plus 2. And I want to know the following. This is where it gets to be a little bit newer for us today. What is f of -4? What does that mean, f of -4? X equals -4, very good. What this means, what is the function equal to when x is -4? So what I do is I go to my equation, and everywhere I see an x, I substitute -4. So f of -4 will equal -4 plus 2, which is -2. Now to check it, since I already had my table open in my calculator, you know how my table started at 0? Press the up button, and then it goes to some negative side. It'll get you that side as well. You can move up and down the table to find values. You could set the table to an ask function where you can type in what the value of x you want it to be, what the input to be. This f of x is the input. It's what's going into the function. What it's generating is the output. It's the y value as it's spitting it out. If you want to switch that share with one in the back, go for it. That's going to drive you nuts. Or take that one. So think of this again. This is your input, and that's your output. It gives you your ordered pairs. Okay? It's a nice little way of doing things. It makes using the calculator real easy when you're doing multiple problems, when you have to do lots of function notation stuff. Okay? Questions on any of that so far? Well, what this function notation is going to allow us to do is get to stuff like this. I'm getting there. But if you look at this here, I've got 4 different functions, 4 different equations. F of x is 7x minus 12. M of x is 1/2 x plus 4. B of x is negative x plus 5. R of x is 2x squared plus 3x. Now, some of you guys got worried faces. Don't worry. All this tells me is to go here. F of 9. Which equation do you think I need to use to solve f of 9? The f equation. It tells you, that letter tells you what equation to look at. It says, look at the f equation. Okay, it's right here. Now, that means everywhere I see a 9, I put, or x, I put a 9, excuse me. So that means f of 9 is 7 times 9 minus 12. What do you get? 51. So f of 9 is 51. Does that make sense?
Yeah.
All you're doing is this is just a fancy way of writing out direct substitution. So try a few of these. Don't worry about these 2 yet. I'm going to talk about those here in a second. But try the rest of those real fast. I'll explain what that happens. Try that car one. It's not as scary as you may think.
What?
All right. F of negative 3. Which equation do you use? F. So f of negative 3 winds up being 7 times negative 3 minus 12, otherwise known as? Negative 33. Very good.
Negative 33.
B of 2. B of 2, which equation? B. So that means we use opposite of 2 plus 5. You get? 3. Excellent. R of negative 4. R of negative 4. Which one do you use? R. D-R-R. Which means you have 2 times negative 4 squared plus 3 times negative 4. Which means you have to be smarter than your calculator. 20. Good. If you type in your calculator, negative, what was it, negative 2, no, it was positive 2, excuse me, 2 times negative 4 squared plus 3 times negative 4. But if you don't, you get the wrong answer. That's why I'm saying you gotta be smarter than the calculator by throwing in parentheses, that's all. Or if you wanted to, you could have used the function. Yes, ma'am?
So when you have exponent variable like that, the exponent is the solution to those 2 problems together? Or they just, okay, when you had 2x with the
Squared, yeah.
Is it squaring 2x or just the x?
Just
And
the
then
x.
multiply by 2?
Yes, it's just the x that has the exponent. If it was 2x in parentheses, then it would be 2x times 2x.
Okay. I'm fine.
Don't poke it. And everybody's favorite M of car. Well, that means which equation to use.
The one with the M.
So we use the one with the M. Very good.
What was R negative 4? Is that 20?
It was 20, yes. It was 20. So that means, do I get 1/2 car plus 4? So is it plus 4?
Yeah.
Yeah.
So it's
Cock
just
plus 4?
1
Cock plus 4?
Yes.
No, I'm confused.
What?
Can you just tell us the
M
answer?
car.
Half of car plus 4. That's it.
And you can't solve
What this is, you're not solving anything. All it's telling you is take the word car and substitute in for x. So you get 1/2 car plus 4. And then you go to the next problem. That's all that means. And it's absurd, it's silly to put it writing like that, but it's literally telling you whatever is in that parentheses, whether it's a word, a number, whatever. You take whatever that is to the specific equation that it's asking you to use, and you substitute that variable, or whatever's in the parentheses, into the x variable. That's all it is. And yeah, I know it's goofy, but that's all it means. All right, so if this was m of potato, it'd be half a potato plus 4. Okay, what, potato?
Yeah, I like potato.
I usually use potato with this one, but I used car this time. I don't know. M of -6. Which one are you going to use? All right, what's half of -6? Plus 4. Very good. Now the last little bit. Oh, I'll get there. The last bit of this stuff here is this. I'm going to change this to B of F of 3. Yeah, when I typed it in here, when I put this in the notes, I accidentally typed it with an X. I meant to put a number in it. We don't need to worry about the other substitutions yet. In this case here, it's asking you what is B of F of 3. Now, it forces you, guys, come on. It forces you to do order of operations here. Order of operations tells you when you're working with parentheses, because all I see is a bunch of parentheses here, go to the innermost parentheses and work your way out. The innermost parentheses in this problem deals with F of 3. You agree?
Yeah.
So that means, what's F of 3? Well, 21 minus 12, I get 9, right?
Yep.
So that means that F of 3 equals 9. So now I get B of 9. What's B of 9? Well, -9 plus 5, you get -4. So when you see those double problems like that with multiple letters, it's telling you to go to the innermost first, find that solution, go to the next one, find it, and continue. Same idea with that M of 4. I'm using the M equation twice, I'm just resubstituting in twice. I go to the M value and I use 4. Well, what's half of 4? What's 2 plus 4? 6. So then I get M of 6. And I get, well, what's half of 6? What's 3 plus 4?
7.
And you get that. It's just telling you to start in the innermost and work your way out. You guys have all done that fourth order of ops, so that's not anything crazy. What's different is that you're seeing it with this new style function notation. This is very, very, very prevalent upon ACT stuff. Instead of seeing F of X, though, you will see the following. What's that?
65.
Instead of seeing it with the F of X on your ACT, you'll see it written like that. Triangle of X is X squared minus 2. What's triangle of 3? Or excuse me, -3. Yeah, you just substitute back in -3. -9? Someone said -9?
It's 12 actually. Pretty sure.
That's 12.
Oh wait.
Oh, no.
So then it's 14.
It's just say it's.
I can't do that. I don't know why
Once again, when we're dealing with weird values and not sure exactly what happens, you can always go to your calculator, go to the y equals portion. You can type in there, what was it? 2, was it x squared?
Minus.
So we just go x squared minus 2x. Go directly to your table. Go directly to your table, and I think I asked for what was f of -3. You just scroll around, there's your answer.
it's so simple.
It is. Don't get those types of problems wrong. There's no reason you should ever get those wrong. especially because I know you guys are going to make your mistake. You'll forget parentheses at some point in time. If you put it in the y equals function on the calculator, it's going to alleviate those issues. It makes it so much easier. Does it take an extra second or two to type it in? Yeah. But you see how it generates the right answer for you? Yes, sir.
If you go to 0 and then plus, you can type in what number you want to go to. Like if you want to big thing.
Yeah.
Go to 0. Otherwise, we'll just add on the negative. Like, forward.
You can also do it where you can change your window, your table set. If you hit second window, you can change that table set right there to go up by halves or go up by ones. So that's how you can change that as well. Or you can send it as ask. And if you change it to ask, it'll say, what do you want x to be? You can say pi, and it'll spit out an answer for you. We'll get into changing these setups usually when we get to trig, because that's the way we can show how things are moving around the unit circle real easy. All right, so that's this. Let's try a couple more here real quick. Where does this get us? This gets us to the following. And this is kind of where we're going to wind up leaving off here today after we go through these couple examples. This gets us into a domain-specific function. This gets us into
7 minutes.
okay, that's what I thought. This gets us into graphing, which we're not going to do today, but it gets us into the idea of specific values of the domain relate to specific parts of the function. Just like I said earlier, when we're looking at the example of overtime, if your value of the amount of hours you work is less than 40 hours, it's in that $10 an hour range. The minute you work 42 hours, you're at the other range. You're above 40 hours. That's $15 an hour. So the equations change depending upon the domain. So like I said, these are domain specific. When x is between -2 and 6, I use this function. When x is between -8 and -4, I use this. So this example here, f of 0. Well, I go f of 0. These are all f equations. Where does the 0 domain, where does this guy wind up in here? Or does it wind up in here? Winds up in the first one, right? So that means I substitute into here, I get 2 times 0 plus 1. What do you get? 1. So f of 0 is 1. What about f of -7? Which equation does it go to? F of -7 sends us into that domain. It's between -8 and -4. So I get negative of -7, which is 7. Very good. All I'm doing is that these equations are domain specific. It tells you which one to choose. F of -3. Does that fit in any of my domain?
Actually, no.
No. It's undefined. It's not in my domain. Is -3 fit in here?
No.
-3 fit in here? No. So I can't do it. I can't do it. All right? I can't generate anything. F of 4, which one did that go to?
Blue.
Goes to the blue one. Goes to the one up on top. You get 2 times 4 plus 1. 9. You okay on that? Okay. So basically that leads us to being able to look at these two graphs via the domains. So what we're going to wind up doing tonight is just some direct substitution problems. And then tomorrow when we come in, we'll start looking at how you plot these things via the domain. I think most of you guys do your math in pencils, so that's good. We want to make sure we have erasers tomorrow because it's the easiest way to do these things. So tonight I've got for us, let me show you what it looks like. Yeah, I cut and paste a couple of things together. I think this is it. Oh, that's 2.8, wrong section, sorry. What I did is I pieced together a couple of these problems like this. There's 24 of them. What I want you to do is all of them, but tomorrow when we come into class, we're going to use the clickers to type in only 12 of them. And I'll tell you which ones tomorrow. Might as well pause this out.